Okay, good evening, everybody. So today we're going to be talking about section 5.5, which is writing equations for parallel and perpendicular lines. And really, there's only one thing we need to really be concentrating on as far as writing these equations. And we'll talk about that here in just a second. So first thing I want to talk about is what your understanding of parallel and perpendicular are. So I'm not sure where our level of understanding for these two words is. I'm assuming we probably have a pretty decent idea of what parallel means. So I'll go ahead and tell you like my understanding of it, but you certainly can write it however you want as long as it's kind of similar, makes sense to what I'm saying. So parallel, when we're talking about parallel lines, those are lines that never intersect. They're never going to cross, okay? Another way you can say about things about parallel lines is parallel lines are lines that have the same slope or the same rate of change. So their delta y over their delta x is the same. Their rise or fall over their run is the same. So the slopes are the same. So when we talk about parallel lines, the slopes are the same, which means that they are never going to intersect. Okay, so again, write that however you understand it best, what parallel means. All right, next is perpendicular. And perpendicular lines are lines that do intersect, but they don't just intersect any old way. Perpendicular lines intersect so that the two lines that are crossing form 90-degree angles. So they form right angles, okay? So two lines are perpendicular if they create 4 right angles when they intersect. So that has to be very specific. It can't just be any old lines that are crossing. They have to be at 90-degree angles. Okay, so the first thing we're going to talk about is what the graph looks like for parallel lines. So I have a line here that's drawn, and it's the yellow line, obviously. Hopefully yellow is showing up pretty decently today. But the yellow line is a line that I'm drawing. Now, if I'm going to draw a line that has the same slope, or the line that is parallel to it, then that line would look something like this. Excuse me, I inadvertently wrote something down. That is not what a parallel line looks like, so let's not think that is. Okay. Alright, so a parallel line looks like this. Okay? So the red line and the yellow line are now parallel, and it doesn't matter where they are on the graph. They're parallel there. They're parallel there, they're parallel there, they're parallel there. It doesn't matter how they are lined up. These two lines that I have here always have the same slope, no matter what. Okay, so those two lines are parallel. Now, let's talk about them being parallel for a second and see if we can prove it. Okay, so for the red line, I'm going to do a slope triangle because that's the easiest way to find the slope. So I'm going to start right here, and I will go to right here, it looks like. And so from here, from my starting point, which is my star and my smiley face, I'm going to rise 1 and run 2. So that's 1 and 2, which gives me a slope of rise of 1, run of 2. Now to do the yellow one, I'm going to use orange maybe. Okay, so I'm going to go, let's say, from this point here to that point there. So there's my starting point and my smiley face. Here I'm going to rise 1 and run 2. So that gives me a 1, 2, which gives me a slope of 1/2. So they have the same exact slope. Okay. Now it doesn't matter how many lines that we happen to draw here. If we are have the same slope, then we have the same slope. So it doesn't matter again where I move it. So there we go, just like that. And then if I'm going to put another line on there, whoops, that's not what I meant to do. If I'm going to put another line on there, then I just need to make sure it has the same slope. So I'm going to go from here, this point here, This time I'm going to rise 2 and run 4 because that would give me the same slope. And I draw my line and that has the same slope as the other two. Okay, so that's parallel lines. All right, so that's what they look like on a graph. Now, take a look at the next slide. For the next slide, we're given some equations. So all we need to think about is the slope of a line. And we'll talk about one other type that we have here. So looking at the slope of a line. So if this is my main equation, y equals mx plus b, and I'm comparing all of the other equations to that one line, then what I care about is that my m needs to be equal to 2/5. That's it. If the m is equal to 2/5, then the equations are parallel. So I come over here and look at this first one, and here is my m right here, and that m is equal to 1/5. Is it parallel? No, because the slopes are not the same. It doesn't matter that the y-intercept is the same as my original y-intercept. That's not important. So the fact that this right here is the same as this right here doesn't even matter. It's only what the slope is doing. Okay, so I come over here and I see that I have m is equal to negative 2/5. Is that the same as m being equal to 2/5? And the answer to that, of course, is no, it is not. Okay, again, what doesn't matter is this y-intercept. Say the y-intercept isn't important here because I care about the slope. All right, go and look at the next one. My m is equal to 2/5. Is that the same as this one right here? And of course, yes it is. So that one is parallel. So this is parallel. All right, so this one here is parallel to that one. Even though the y-intercepts are different, that doesn't matter. It's the slope. All right, now this one's a little bit trickier because it's not written in y form. So no big deal. All I got to do is get it into y form first. So now I have y equals 2/5 x plus 1. And so my slope here is m is equal to 2/5. And so is that parallel? And the answer to that is yes, it is. Okay, because the slope is the same as this one up here. Right? I'm always comparing it back to that original problem. All right, and then lastly, this last one over here, we see that it's quite a bit, it's in standard form, so we need to change it. So the first thing I'm going to do is subtract 2x from both sides. And I get negative 5y equals negative 2x plus 15. And then I'm going to divide both sides by negative 5. And I get y is equal to 2/5 x minus 3. Okay, now, so what we notice then is that our slope is equal to, m is equal to 2/5. So our first reaction might be, yeah, that's parallel, because this slope right here is the same as that slope right there. And this whole notes I've been saying, if the slopes are the same, then they're parallel. But they're not parallel. And the reason they're not parallel is because the way this equation worked out is this equation right here, this line, is the exact same as this line right here. The reason it's the same is because they have the same y-intercept. So the y-intercept is negative 3, the y-intercept is negative 3, the slope is 2/5, the slope is 2/5. Therefore, they can't be parallel lines. They are the exact same line. So then this is no, not parallel. Okay, that's not parallel because the y-intercept and the slope are exactly the same. If we come back to this one right here, this one was parallel because it had the same slope, but it had a different y-intercept. This one over here was parallel. It had the same slope, but a different y-intercept. So what has to be true is the slopes are the same, but the y-intercept is different. Okay, now we're going to talk about perpendicular. So for perpendicular lines, if they're right angles, then they're perpendicular. What we want to be able to do is to prove that they are perpendicular. And the way we prove they're perpendicular is by looking at their slopes. So the very first thing I'm going to do is I'm going to look at the slope of the red line. Okay, so for the red line, I'm going to start right here. Looks like that looks like a decent point to start at. And I'm going to go to this point right here. Whoops. So from this point, I'm going to go down first, and then I run to the right. And since I went down 1, 2, 3, 4. So that's -4. Hopefully this orange is showing up okay. And then I ran 1 to the right. So that's my 1. So my slope, m is equal to -4 over 1. Okay, so that's the slope. For the red line, m is equal to -4 over 1. Okay, then I'm going to do the blue line. And for the blue line, I'm going to start, let's say, right here. And I will go to right there. And so from here I go rise 1, and then I run to the right. So I rose 1 and ran 1, 2, 3, 4, and that's 4. And so for the blue line, my slope is equal to positive 1/4. Now, what you're looking at these two slopes, well, these slopes are completely different. They're the different signs, and they are inverses of the other, or reciprocals. That is what makes two lines perpendicular. So if the slope is the negative reciprocal, okay, the negative reciprocal, reciprocal, okay, the negative reciprocal, the slopes are, the lines are perpendicular. For what doesn't matter on this one is the y-intercept. It doesn't matter. So if one of your slopes is, if m equals rise over run, then the perpendicular would be run over fall. Okay? So if one of them is m is equal to y over x, then the perpendicular would be -x over y. Okay, so it's the negative reciprocal. It's going to be the opposite sign, and it's going to be inverted or flipped over. Okay, that's tricky to remember. All right, take a look at some equations. All right, here we go. We've got a bunch of equations, and just like on the last one, we're going to use this one as our main one. So here, the only thing I care about is my slope is equal to 2/5. So what I am looking for are slopes that are the negative reciprocal. Okay, the negative reciprocal. So I come over to this first one here, and I see m is equal to -2/5. Well, when I look at that, I like the fact that it's negative, but it's not the reciprocal of it. It's not flipped over. Therefore, this is no, not perpendicular. Okay, this one is not perpendicular because it does not have the negative reciprocal. Next, I look at this one. And this one is m is equal to 2/7. That isn't even the same slope at all. So while it's a different slope, it's not the negative reciprocal. So this is no, it is not the negative reciprocal. So it's not perpendicular. I look at the next one here. M is equal to 5/2. It is the reciprocal, but it's not the negative reciprocal. So again, no, not perpendicular. Okay. Now I look at the next one here. And we have m is equal to -5/2. It is the reciprocal of our first one, so this one right here is +2/5. This one here is -5/2 for my slope. That's the only thing I care about. I don't even care that there's no b or that the b is 0. I don't care about that. So this is, yes, it is perpendicular. All right, look at the next one here. It's a little bit tricky to tell because it's not in y form. So the very first thing that I want to do is put it into y form. So I'm going to divide by 2, divide by 2. I get y equals 5/2 x minus 7/2. So I see that my m is equal to 5/2, and that is the reciprocal, but it's not the negative reciprocal, so no, it is not perpendicular. And then I have my last one here, which is obviously in standard form, so I need to change that completely. So the first thing I'm going to do is subtract 10x from both sides, subtract 10x from both sides. On the left-hand side, I get negative 4y equals negative 10x plus 12. And then I'm going to divide both sides by negative 4. And I get y equals, that simplifies down to 5/2 x plus 12. And again, what I notice here is that my slope is reciprocaled, but it is not negative, so then this also is no. It is not perpendicular. So this line is not perpendicular right here. This line right here is not perpendicular to this line up here. Each one of these lines, that one, that one, that one, that one, that one, and that one, are all being compared to our original line. Is it the negative reciprocal for that slope? Okay, we look at each slope. That's the negative but not reciprocal. That's reciprocal but not negative. That's a completely different slope. That one is reciprocal and negative, so yes, it is. This one, once we put it into y form, is not negative. Once we put this one into y form, it is not negative. So some of them had some issues as far as being able to tell, like this one and this one, y form, and then we can tell. Okay, I know the notes are a little bit long tonight, but I know you guys can handle it. All right, talk to you later.